Okay, guys, what we're going to do is we're going to do practice problem 1 on page 175. And it says, using an MP3, how many bits are required to store a 3-minute song in uncompressed format? If the information is compressed with a ratio of 4 to 1, how many bits are required? So in order to do this, what we're going to do is we're going to look and say, all right, a CD is normally recorded at 44.1 kilohertz, which is 44,100 samples taken every second. So we're going to use that. So we're just going to write that down. 44,100 samples, all right? So we say 44,100 samples. And we're going to say the song is 3. This is going to be the sample rate, because we need that. The book doesn't really put a sample rate down. I'm just making one up. And it's a 3-minute song. So we'll say 3-minute length. All right? And there's a 4 to 1 compression ratio. So let's just go through a few things. We'll go through number 1. How much memory would we need to store the song uncompressed? We'll do that. Let me just do a little split the screen here. Oops. Let's just do that. Let's just do, this side will be uncompressed. So I'll put UC for uncompressed. And this side will be compressed. All right? So how many bits of data would we need for an uncompressed file? Well, we're going to take the sample rate, 44,100, and we're going to multiply it by the following. There's 60 seconds in every minute, and this is a 3-minute song. So we're going to multiply that all together. And this is bits per second. This is, if you look at the sample rate here. Let's see here. Let's see here. Yeah, we'll just say it's bits per second. All right, so I'm just going to go ahead and say, do this on the other screen real quick. So we're going to say 44,100 times 60 times 3. That is 793,800. So 793,800. So that's about roughly 8 million bits. Let's figure out how many bytes that is. So we're going to take that number and we're going to divide it by 8, because there's 8 bytes per bit. So if we divide this by 8, we're going to get 99,2250 bytes. So it's about a meg. 1 meg is a million bytes, right? So it's about a meg. All right. So we're going to compress it. So we're actually going to compress the bits just to make our life easy. So we're going to take 7,938,000 bits, and we're going to divide it by 4, because that's the compression rate. This is still going to be in bits, okay? Everything's still in bits here. We're not changing anything. So 7,938,000 divided by 4. So now we're down to 198,450. 4500. So we went from 7 million bits to about 2 million bits. And let's just divide this by 8 to get the bytes. So it's 248 0.062 bytes. So we went from originally about 1 million bytes to 250,000 bytes. That's really good. That's a lot. That's a nice compression ratio. So you saved a lot of hard disk space. All right, so that's number one. Again, you have to come up with a sample rate, otherwise the problem doesn't make sense. Usually it's 44,100 for a compact disc sample rate. That's just pretty standard. You can do 128,000. There's also stuff called like lossless audio compression. There's a lot of different ones. Uncompressed, whatever. We're just going to keep it that. Hopefully that made sense. The whole idea is you take your sample rate, you multiply it by the number of seconds per minute times the number of minutes, and you get how many bits that total data that's going to be stored in your hard drive. When you divide that by 8, you get the bytes, right? Then we take our original bits and we divide it by 4 because that's the compression rate. The compression rate is 4 to 1. Hold on a second. Right, the compression rate's 4 to 1. And we notice that we cut it down by 25%, right? So if we were to multiply 9992250 by 0.75, it's actually a little bit more. Let's see, I think it's 0.992250, sorry, times 0.25. Yeah, so it's a quarter of the original size, which is really great. You saved 75% of the bits, the original bits, which is a lot. That means, that's a lot. That's a huge savings. That's 75% savings. All right, so I'm going to pause the video, and then we'll go ahead and do another example.
We've known it for years.
All right, guys. So let's take a look at number 4. It says if we want the image, how many bits of data are needed to store a single uncompressed RGB image from a 2.1 megapixel camera? How many bytes of memory is this? Again, this is a little bit incomplete, the information here. So let's just make this problem a little bit better. What we're going to say is we're going to have a 24-bit image, all right? So we're going to say every pixel has a 24-bit encoding. That's for, the color and everything like that. So just a quick thing, like let's pretend like this is a big picture and there's, all these pixels. By the way, 1 megapixel means 1 million pixels. And each one of these pixels, right? Each one of these pixels represents 24 bits. Now what's 24 bits? It looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So every single one of these tiny pixels has a 24-bit code. And this code tells you the color, right? This is just broken down to some color algorithm that, is standard for, you could Google RGB colors and get the idea. All right, so how do we figure this out? All right, so what we have is we have 2.1 megapixel camera, right? 2.1 megapixel. That means there are 2,100,000 pixels on the screen. Each pixel is represented using 24 bits. So we're going to multiply this by 24. And we're going to get a really big number. So what do we get? What do we want? We'll do this with bits first, and then we'll convert it to bytes. So it's 24 times 2,100,000. I think I did that right. Yeah. Okay, so we get 504, 1, 2, 3, 4, 5. We get this. 504, 1, 2, 3, 4, 5, comma. So we get 50,400,000 bits. Now, the book doesn't want the answer in bits, it wants it in bytes. So how do we go from bits to bytes? We divide by 8, right? We divide by 8, because there's 8 bits per byte. So we're going to divide this by 8, and we get 63, 1, 2, 3, 4, 5. So we get 63. So we get 6,300,000 bytes. So that's how much memory. That's how much memory you would need. Now, yeah, that's it. Hopefully that made sense. You have to do some assumptions, right? You have to assume, is it 24-bit? Is it a 16-bit? Is it an 8-bit? You could choose that. And based on that, you'll have less memory. But that's how to do that problem. All right, guys, let's look at problem number 7. It seems kind of wild. So a smartphone has 16 gigabytes of memory available, okay? And we have a 3-minute song. We'll assume every song is 3 minutes, I guess. And it uses a sampling rate of 44,100. Bits per second. Actually, 44,100 samples per second. And we know that each sample is 16 bits. So it's a 16-bit depth. 16 bits per sample. Okay? And it has a compression ratio of 10 to 1. So that means it's 1/10 of its original 10 to 1 compression ratio. Okay, so we have 16 gigs of hard drive space, 3 minutes per song, 44,100 samples per second. Each sample stores a 16 bits to represent the song, the sound, and there's a 10 to 1 compression ratio. How many songs can be stored on our phone? Okay, the thing you have to know is 1 gig has 1 billion, this again, I just looked this up, 2 to the 30 bytes. So, has 1 billion, 73 million, 741,000, and 824 bytes. So 16 gigs is 16 times that. We're going to say, to keep this simple, 1 billion bytes. We're just going to say 1 billion bytes. So we're going to say this is roughly just simply 1 billion, because I don't feel like writing all those numbers, and we'll get roughly the same answer. If you really want to, you could do it on your own with the exact value. Roughly 1 billion bytes. So our hard drive space, in other words, has 1 billion bytes per gig times 16. So that's 16 billion, excuse me, 16 billion bytes available, okay? Excuse me. All right, so this is how much space we have available on our hard drive. We're just gonna store that away in our memory. We're gonna pretend that's our memory, okay? And let's figure out how many bytes each song is. We're gonna figure out how many bytes each song is. So we're gonna say each song is 3 minutes. So we're gonna say 3 minutes times, well, there's 60 seconds per minute, times each second has 44. Each second has 44,100 samples, and each sample has 16 bits. Right? So we have to multiply 3 minutes times 60 because there's 60 seconds per minute times 44,100 because every second has 44,100 samples. It's quite a bit. Times 60. Let me just make sure I read that right. Yep. All right, so let's use a calculator really quick and do this because I'm not going to do it here. 3 times 60 times 44,100 times 16. And we're going to get 127,008, and then another 3 zeros. 127,008,000 bits. We don't care about bits, all right? We don't care about bits. We need to convert this to bytes because our memory is expressed as bytes. So we're going to divide this by 8. So let's go ahead and do that. Actually, let's not do that yet. Let's divide it by 10 first because that's the compression ratio. So we're going to take that number and we're going to divide it by 10 because our hard drive is only going to store 1/10 of those bits in a hard drive because that's how it's getting compressed. So all we're going to do is we're just going to boop. We're going to cross off a 0. That was easy. Okay, we're done. Now we're going to divide that by 8. So we're going to divide 12,070. Let me see here. Let me just rewrite the number and then I'll put it in the commas. 127,008,000. 12,700,800 bits is stored on our hard drive. So we're going to divide that by 8. And we are going to get divided by 10. Just kidding. Nope, divided by 8 because we're converting. We already did the compression ratio. We're converting it to bytes. And we get this. We get 1,587,600 bytes. All right, so now we figured out how much bytes every song is. Whew. Okay, this is a lot of arithmetic. So now we know our hard drive has 16 billion, so that's 100,000 million billion, so 16 billion bytes. If each song is 1,587,600 bytes, how many songs can we have? We're going to round this to just simply 1,500,000. Right? We're just going to round it a little bit. We're going to round it. It's not a big deal. 1,500,000 bytes. Remember, because we rounded that a little bit as well. Okay, so let's go ahead and do some division. So we're going to take 16 billion. These numbers are huge. And we're going to divide it by 1,500,000. Okay, so let's do that. So 16 billion divided by 1,500,000. That's 4 zeros, 5 zeros. Okay, this is roughly 10,666 songs. So we'll say 10,600 songs. About 10,000 songs. So we'll just say it's about 10,000 songs. It's about 10,000. A couple more, like 10,600. It's about 10,000 songs. So if we have a 16 gig hard drive and the sample rate, each song is 3 minutes. We have a 44,100 samples per second. It's 16 bits per second depth rate. at a 10.1 compression ratio, we can store about 10,000 songs. All right, that was a lot of arithmetic. Shoo, but we're done. Yay. Okay, so thanks for watching.